Welcome to Rachel's classroom. In this video, we will be discussing a couple of problems on internal rate of return method in the series of evaluation of capital budgeting proposals. So IRR is the rate of return at which the sum of the discounted cash inflows is equal to the sum of the discounted cash outflows. So it is the rate at which the net present value of the investment or the cost of the project is 0. We call it the internal rate because it entirely depends on the investments or the cost of the project and the cash flows associated with the project, and not on any rate that is determined outside the investment or the project. So this method is also called as marginal rate of return method or time adjusted rate of return method. We usually use this method when we know the cost of investment and the cash inflows, annual cash inflows, while the unknown rate of return is to be calculated. So let's proceed into the video. The first example I've taken here is that of an organization that wishes to invest in a project which requires an initial investment of 2 lakhs. It is expected to generate a cash flow of rupees 80,000 every year for 4 years. So this is the example of a uniform cash flow. So in this case, how do we calculate internal rate of return? So the first step here we do is we have to find the PV factor value. So to find the PV factor value, we will divide the initial investment by cash flow after tax. So here initial investment is 2 lakhs divided by cash flow after tax 80,000, which is 2.5. After we have determined the PV factor 2.5, we know that the cash flows is for 4 years. So we go to the PV present value annuity table. Okay, and we go select the time period 4 years. And we search for 2.5 in the 4 years row. Okay, so we are trying to find the IRR for 4 years. So we will have to select the row for 4th year and start looking for 2.5. So 2.5 22%. At 22% we have 2.49. So at 22% we have the PV factor of 2.5. So the PV annuity table shows the closest factor to 2.5 is 2.494 at 22% rate of discount against 4 years. Thus the IRR is 22%. So the economic implication in this case is that the organization should invest in a project only when the cost of capital is less than 22%. If it is more than that, it won't be profitable. So let's see one more example under this same internal rate of return method. Here we have another problem where they have 3 options: machine A, B and C, and they've given the returns for 6 years and the initial cost also. So we are going to find IRR when there is differential cash flow. So let's start with the first A option. So as usual, the first step is to determine the PV factor. So in this case, the initial investment is 60,000 divided by average cash inflow. To find the average cash inflow, you have to add up the second column, inflow values, and we determine that it is 81,000. So 81,000 divided by 6 years will give you 13,500. So the PV factor is 4.44. So we have to go to the present value annuity table to find the percentage. So we go to the annuity table and start looking for 4.44 in the 6th year, again sixth year. So we can take 8% and 9%, which are the closest values, and try to find the IRR rate. So as we decided 8% and 9%, we'll note down the PV values from first year to the 6th year. We multiply it with the each year's inflow and find the present value for each year, and we find the total value of present value of cash inflow. Here in this case at 8% it is 61,593 minus present value of total cash outflow. Cash outflow only the initial investment value. So 60,000 into 1. So the difference, the net present value is 1,593. In the case of 8% it is positive NPV, and in the case of 9% it is negative NPV. Okay, this is total cash inflows minus total present value of cash outflows. We will get the net present value. Okay, so the next step is we substitute it in the formula. To find IRR, we use this formula: lower rate plus positive NPV divided by differences in the calculated present values into difference in rate. So the lower rate, out of 8 and 9%, 8 is the lower rate, so 8%. Positive NPV, we have one negative NPV and one positive NPV. So 8%, at 8% we have a positive NPV, which is 1,593. So we take that 1,593 and we find the differences in the calculated present value. Calculated present value is 61,593 minus 59,621. Into the difference in rate, 9% minus 8%. So the IRR for machine A is 8.81%. Similarly, we will find out for machine B and machine C. So first step is we find the PV factor. So in this case, initial investment is 66,000 divided by the average of inflows. You add up the inflows. We find it as at 90,000 divided by the number of years, 6 years. So 90,000 divided by 6 years is 15,000. So the PV factor is approximately 4. We go to the annuity table and try to find 4. So here in this case it is 13% and 14%. We usually have to iterate to find the closest value. So here it is 13% and 14%. These are the two closest value to 4. Usually it is preferable to take the lower value. So 13% and 14%, you will write down the PV values and multiply it with inflows. Find the total present value of cash inflows and subtract the total value, present value of the cash outflow. So here one is positive and the other is negative. So we substitute it in the formula. 13 is lower rate plus positive net present value, that is 198, divided by the difference in the calculated present values. Here in this case it is 66,198 minus 64,800. So the IRR for machine B is 13.14%. In the case of machine C, again we have to calculate the PV factor. Here it is 4.8. Go to the annuity table. We can choose 7% and 8%. So the IRR is 7.08%. Thank you.